I would like to give you a summary of what can be and what cannot be factored. Let's start with this one. This is famous difference of squares. You should not struggle at all. When you see difference of squares, you should just come up with x plus y and x minus y. Some of you want to say, I prefer x minus y times x plus y. That's perfectly fine. Either one will work. Now, what about this here? If you struggle with this, then you didn't learn enough. This is a famous prime. This cannot be factored. You could try all kinds of things, but the proof is in the foiling, right? If you think, oh, it should be this. If you foil that, you get x squared plus 2xy plus y squared. Do it yourself and find out. So this is not true. So therefore, this cannot be factored. So what do you say when you see a problem like that? You just put down, so this is nothing to do with the problem. All you got to do is just put down prime. That's it. This cannot be factored. Okay. Now, what if it's a difference of cubes? What do we do? This you got to learn, and this turns out to be x minus y times x squared plus 2, not 2. I was going to say, be careful with it, and then I did it. There we go. Now, why this works? The proof is in the foiling again. Just foil it, and you see it comes out to be this. It's impossible for you to think of this when you see this one here. There are some techniques, but if you know those techniques, you know this already. So this is something that you have to just know. You got to recognize the pattern. You should not have to think about this. So this is difference of cubes. This is what I do to remind myself how to do it. That is, you write this problem as if there are no cubes. So I got these, right? And then you put this one that looks very much like this, right? You've seen that. But it doesn't have that 2 in it. So that's what you get. Why? Because when you FOIL, you get this. That's all. Okay, and then what if it's difference of cubes? I mean, it's a sum of cubes. Then you remember this and say, this was prime. Is this a prime? But this is 3. Does it make any difference? And the answer is it does. And the answer is x plus y and x squared minus xy plus y squared. I'm just telling you the facts here. I'm not teaching you how to do these, so you got to learn from your teacher. But this is the answer here. One trick of remembering it is exactly the same as this. Just write this down as if there are no cubes. And then write this down as if it was a perfect square, like that, right? Except you don't put 2 there. That's what you do. Here's one thing you have to remember is that if it's negative here, you got to make this positive. If it's positive here, you got to make this negative. Why? Only then, when you FOIL this, you get this result. It all boils down to that. Why are we doing this? Why is that? Why is this rule? There are no rules, except for one. When you FOIL, you got to get this. That's it. So you may want to stick in 2 here because it looks better that way. But you shouldn't, because when you FOIL, you don't get this. That's all. Okay. Now, we got this cubed problem. So I'd like to go back here. If these are cubes here, whether it's difference or sum, it is factorable. Cubes are very flexible. It doesn't matter what you do. They will factor. So you get that. What if they're fourth powers? And you say, oh, the 2 and 3 behave differently, so 4 must be very different too. Or does it look like this? What do we do? In this case, you got to think of this as cubes here. That is, I got to see this x squared squared minus y squared squared. So I have something squared minus something squared. Oh, I know that. I've done that. Okay, then do it. So what is it? Well, the something squared minus something squared was something plus something. So I will say that's something plus something. I'm ignoring the fact that these are squares inside. I'm just seeing the whole parenthesis, and I'm blind to what's inside. And the whole thing times, now I'm doing this part here, something, first thing minus second thing. So first thing was this minus the second thing, which was this. All these extra parentheses make it look messy, so I will just write without one. So that would be x squared plus y squared for the first guy, and x squared minus y squared for the second guy. Then, this is the crucial point. If you stop here, you get it wrong. This, you've seen this before. Yeah, it's this. So you got to do it again. Okay, I'm running out of room, so I will come here. So here, I have to copy the first part. And then this one, I got to do this operation here. So this guy becomes x plus y and x minus y. Okay, then you say, I don't believe you anymore. I thought I was done and there was something else lurking behind. So I feel uneasy stopping. I feel I got to get going, you feel, right? Then you examine very carefully, and there are no powers, so obviously this cannot be factored. Factoring is breaking into multiplications. There are first power everywhere. That means they are not multiplied by anything except for 1 in front. So this cannot be factored. Oh, second power. Promising this could be factored. But you remember, this guy was prime, and that's what that guy is. So this is done. This is the end. Okay. Now here comes the fourth power added. What do we do? Can we do anything? As it turns out, this is a prime if your coefficients have to be rational. Sorry. Yeah, rational, that's right. If the coefficients got to be rational, this is a prime. So for most cases, this is a prime. But this problem can be tweaked into this shape here. And the whole reason I'm teaching you this is because of this one here. I'm going to doctor this a little bit because normally this is impossible to factor, but I'm going to do something so that I can show you a trick we can play. X to the fourth, I meant to do x to the second power plus 2y squared to the second power. Okay, now this is sum of squares, and I told you this is prime, so this is a prime. That's right. So what do we hope to do here? Here I'm going to make a devilishly sneaky move. What I'm going to do is I'm going to say x squared. I'm just copying it. So far it's harmless. 2y squared. In here I'm going to stick in 4x squared y squared. Can you do that? No, you can't. But if you subtract it, then it's okay. I can say, hey, I'm clean. I didn't add anything. This adds up to 0. So this is fine. But why are we doing such a thing here? That's because, do you notice this here? This is a perfect squared. I will show you a little better here. X squared plus 2 times x squared and 2y squared. That's what this guy is. And the second one, the third term is 2y squared. Now you see, this is the form of a squared plus 2ab plus b squared, which can be factored as a plus b squared. Aha! So this thing, well, I should not forget this. 4x squared, y squared. So this is a perfect square, just like this. All you got to think is all you got to do is think of x squared as a and 2y squared as b, and then you see it comes out this way. And then, so this is a perfect square, so it's asking you to be factored. That's what it becomes, right? This was a sideshow for your reference. Okay, and of course this guy is sitting there. We got this. And then you may say, so what? I mean, you're subtracting here. It's not a factoring. So why are we going through all this? The reason is I have x squared plus 2y squared for the first term. And the second term happens to be 2xy squared. Well, before you know it, you have difference of squares. This can be factored. Should I use that trick again? It's nothing more than a squared minus b squared. Maybe I should use a different variable this time. I will use c squared minus d squared. Oh, so this will turn out to be c minus d, c plus d. So this was a sideshow. Okay, so equal sign goes there. So I say, okay, so this guy is c, this guy is d. So I have x squared plus 2y squared minus 2xy and x squared plus 2y squared. Here, all I did was to copy this one, right? And then I'm adding, because once I subtract and once I add, I'm adding this one, 2xy. Wow, who would have thought, right? But it's true. If you FOIL this out, you get this. So all the fourth powers cannot be factored normally. If you have this clever coefficients in some places that could turn the second one into a perfect square like that, and the middle term you stick in to make it perfect square also happens to be a perfect square. That's important because we got to be subtracting a perfect square here, so that we can have difference of squares. So if you have this coefficient in such way that if you force this to be a perfect square and the middle term becomes a perfect square itself, then this problem becomes solvable. Normally, you don't write the answer this way because it got to be in a descending order of power. So you would put x squared minus 2xy plus 2y squared. This was squared. And x squared plus 2xy plus 2y squared. Then, so this is that. Hard to believe, right? You may be nodding now, but doesn't mean that you got it. So please copy this down and do the problem yourself. If you get stuck, come back and watch this and do it again. Do it until you can completely get this. After you succeed, I have a bonus problem for you. That is 4x to the fourth plus y to the fourth. Do this problem. I don't give you a solution. You give me the solution. Okay?